together. If we all stand together, we can do this together. If we all
47 years of HVAC. Well, just see, how did that happen? It was kind of a fluke. I got out of the Air Force. I went to University of Nebraska. Thought I should be in physics, right? Because airplanes were great. Dropping fighter aircraft were fantastic at the time. I enjoyed it. I enjoyed playing with those fantastic toys. Both in the United States, we'd fly up to Alaska for cold weather operations. We'd go down to Panama Canal for practicing jungle warfare. And then we'd go to Vietnam or Thailand to do a real war. But anyway, when I decided physics wasn't for me. This was back in the time when you literally could not get gasoline for your car in the early 70s. Mid 70s, there was gas shortages. You'd sometimes park your car, leave it overnight, get back there early in the morning so someone wouldn't get around in front of you, but just so you could get the gas. So energy was a big deal back then. Fast forward to today, it's global warming as a result of energy, right? So I said, let's get into solar engineering. So I can go to Colorado and I can continue skiing that I learned in the East Coast when I went to school in Connecticut back years ago. So moved to Colorado Springs, went to a school to get a solar thermal degree. But while I was working there, I ended up working with the Dean of Engineering, who was an Air Force Academy professor, but he also had this little private school that he was part of. And he was doing energy audits. And we analyzed facility. He was doing mostly military bases, but he did pick up a Bible college in Colorado Springs. And it was it was a church, it was a college. It had, about 25 buildings, and it was a religious school, post high school, obviously. And so I went to every building that he made. That's going to be your senior thesis instead of doing a solar design, which I know you can do. So I assembled all the information for everything in a building. Everything was electrically connected to gas or electric. So I basically was the beginning of facility management, finding out what makes a building tick. And you couldn't Google things back then. You actually had to put a stamp on something, write out your question, and send it to the manufacturer's address that you found on the data plate of a unit. So once I assembled all this information, the volts, amps, so we could do energy audits on it. Anyway, so that's kind of what started me. Then I took off to go to visit my father, my parents up in Wisconsin. He was a superintendent of schools up in West Bend, Wisconsin, north of Milwaukee. And my thought was to go to, and one of the programs we used was Train's energy management, or a Trace program, which was a energy analysis program. So I worked strongly with the Train local office in Colorado Springs. And that was the introduction to commercial industrial air conditioning vendors, the manufacturers. So when I got up to Wisconsin, they were in La Crosse, which on the other side of the state from my parents. But sitting in my dad's office before we went to lunch was a guy from Johnson Controls. He was the service manager for Johnson. And he just happened to be up there that day to pick up his check for my dad's school district. Had two high schools. They were connected, east and west, but they shared the same basic facilities, including the big chillers that kept the thing cool. So he handed over the check. The school district would pay once a year for that service. And he was talking to me about stuff. And my dad had told me to bring that book along from the Bible college. I think he had something on his mind, but so he asked about it. I said, well, show him that book you did. So I showed him this book, and of course, it's everything that Johnson Controls service people do, right? They go to a building and they take care of everything, the boilers, the chillers, the air conditioning, not always the lights and that stuff, but he goes, what are you doing this afternoon? And I said, nothing. Just not big. So I went to Milwaukee. He got me into the HR. They interviewed me. I had a job with 3 months left in school. and I could pick anywhere I wanted to go. I picked Albuquerque because I didn't want to go to Salt Lake City. I'd already been there. But anyway, Ray knows why I didn't want to go there. But
I sure do. We actually spoke a little bit about this last week, and there'll be a blog summarizing, Steve, your whole career. And I just want to let people know too that I am filling in for Ted this afternoon. Ted Atwood, the CEO of TrackRef. He's got another appointment he had to get to. So I'm signed into his account, so it shows me as Ted Atwood, but I'm clearly not Ted. But Steve, you go ahead. I'm so sorry. I just wanted to make that clear to people.
There's times when I wanted a shot and a beer, and you can't do that in Utah. So you can only have
No,
one drink at a time.
can't.
Very, very strict rules there. So Albuquerque was everything I needed. I lived on the side of a mountain, and it was 3 miles from the ski tram. I could get on a tram 3 miles from my house. So that was always great. It was reverse of Colorado Springs. Colorado Springs, I had Pikes Peak at my back on the west. So it got dark in the winter at like 2 o'clock in the afternoon because Pikes Peak blocked the sun. Now Albuquerque, you flip it around. I was always complaining at 5,280 feet that it was hot in the summer because that sun just kept beating on you all day. But that's where I started with in the HVAC industry. They hired me as an engineer, which was the first. That usually they didn't take engineers as service sales. They were going to move me into controls because I had a background in controls from the Air Force because I did avionics, all those flight control systems and bombing computers, and I'll link that to the industry at the time and how it evolved. So that's part of what we're doing here today. And then it'll eventually, we'll move into compliance and what was then, meaning 1990s, what's now, and how similar some of these things are. So moving forward, we happen to have a company called Mountain Bell that had 77 buildings throughout the state of New Mexico. And we took care of every one of those buildings. We were the facilities management staff and the people that we had people in the buildings and some of the bigger buildings in downtown Albuquerque and up in Santa Fe. But we did building rounds. We kept those buildings running. We started building a new data center for them. But so it was a very, it was helped me transition rather quickly from aircraft maintenance into facility maintenance. That's when I got to know the technicians. I got to know that they specialized. We had chiller people, the big chillers, water-cooled chillers where you had a cooling tower attached to it. Those guys were prima donnas. Then we had the air-cooled guys, whether it was a little 5-ton unit like you had at your house or whatever, or a window unit, refrigerators. Then we had, we ran the wind tunnel out of Kirtland Air Force Base. So we had ultra low temp Cascade people that ran this thing to meet Air Force specs for the temperature they wanted to achieve in that wind tunnel when they were testing different things, because that's what Sandia National Labs did, was make things, top secret things, along with Los Alamos. And then we had White Sands Missile Range for the really cool stuff. This was the beginning of Star Wars. I got involved in that. We had to build a 747 with a laser in it, just to shoot things down. But you had to clamp, when it was on the ground, you had to clamp air conditioning to it and refrigeration so that you could keep all the computers and the laser pieces and parts cold. So it was a fun time, technology-wise. And the solar power tower there at Sandia, where they would focus solar, they were just reflectors, take the sun and focus it on a boiler. Basically take a big Suburban, about the size of a Suburban XL SUV. Imagine that's all metal and it's full of a liquid. Typically it's like Dowtherm, and they would focus those panels on that thing, and it's all black, and it would heat up that Dowtherm, and it would be about 2,800 degrees. Then that would then transition down through heat exchangers and eventually hit water to make steam. And the steam then turned to a steam generator, to make electricity. So this was all in the stage. So I got involved in the controls on that. But this was an early time. The controls at the time were like my airplane. My fighter plane had little round gauges everywhere. And sometimes they were square, but most of them were all round. You had to access them from the back. Unscrew them, screw them in, put them in and out. At the time I got to HVAC, everything was pneumatic controls in big buildings. Okay, so either electric or pneumatic. Very stupid. 20 pounds of air pushing on stuff. So it would open a valve or open a damper. Okay. So what was I doing in airplanes? We were using hydraulic fluid to move ailerons, flaps, and all this good stuff. So the technology was there. If you looked in a cockpit today, what do you see? You don't see many gauges. If you have few, but it's all flat screens. So at the time I was there, as they moved me out of service, that's where I got the knowledge to work with technicians, to know what was going on. Because what's a fundamental part of compliance? You got to walk in the shoes of the guys that do it. So you know how to beat them up when they're not doing the paperwork right? That's how I looked at it. So I moved into the controls business, and it's as the digital revolution was coming, after the MGM Grand burned down in '79, about 12 of us offices all went to Vegas to redesign the new MGM, not the new one, but it became a different casino. We had to rebuild it. And so we started putting in digital controls at the time. So that we could control the building with some intelligence, but it was right in that interim period. So you had pneumatics down in some places with an overlay of computers and things, telling the pneumatics what to do, because the actuators for valves and dampers that industry hadn't kept up as quick. It did in the high end, but if you went to a industrial plant, but where you could afford a $4,000 actuator to move a damper, that was great in an industrial environment, but not in the building HVAC. So this was the early times. I left Johnson Controls after 6 years, and then basically went to the Trane company and helped them get into the integrated comfort systems, is what they called it. They hired me and another controls guy to actually bring that expertise from the field into the Trane company. The designs for the digital controls were going, but how to implement, get it out into the field. You need to have somebody that had walked in those shoes, like a sales engineer from Johnson Controls. Mark was from, I forget what his control company was, but we basically expanded from 5 offices doing controls to 120 in 5 years. So that was the revolution. At that time in the industry, energy was becoming more important. Remember I said earlier that things were happening. So I saw that when I'd go up to Los Alamos and things, because of my Q clearance, they wouldn't have to hide stuff from me. So I'd walk through these areas, and they had these amazing they weren't flat screens. They were the big tube TVs, but I could not believe the clarity. We didn't get this for another 10 years outside of the top secret stuff, but it was the CAD CAM, computer aided design, which would then feed information over to the manufacturing side so they can make nice missiles and whatever it is they're making. But I was amazing at this technology. Now, look at I'm at Trane company, mid 80s. We're doing controls. They're taking chillers now. They're simulating refrigerant flowing through a big centrifugal chiller. They're taking that straight into manufacturing so they could manufacture the wheels so they could get the same gas flow patterns without having to experiment or build this one and build that one and extrapolate between, is what they did before. They just build something, measure the cooling tons, and then the KW performance, because they meter it. Now they could do that on a computer screen. So this was where energy efficiency started coming. In the direct expansion, air-cooled stuff, it was always two pounds per ton of refrigerants. I was looking at stuff that were given me the other day. We're down to 1 pound per ton in packaged equipment now of refrigerant per ton of air conditioning. So they brought this down. That's how they've tried to keep the prices the same, because they engineer all the weight out. If you looked at a 200-ton centrifugal chiller, which was back in the old days, it was huge. Today, it's a tiny little footprint, okay, to do the same amount of cooling, because they've engineered it due to this stuff. So high tech hit the HVAC industry starting in the 80s. We brought the digital controls, direct digital control to variable air volume boxes. So now we had right down to a room or a group of rooms. We knew the airflow to that room, the temperatures coming in and going out. We could really fine tune without having to send a guy out. I remember walking through a lot of my hospitals, the customers, and there'd be 25 people at a big hospital campus that were in maintenance and operations, air conditioning. And I'm like, In today's world, no. They didn't have those overstaffed positions anymore because now we've got controls we can rely on. We can get that information. The big data is now coming at you. So that's all transitioned. You know, refrigerants were cheap. We thought Freon, you know, the CFCs, all those refrigerants we used back in my 80s and stuff, we didn't really fix anything unless something broke, except for pharmaceutical because they had to validate operations. If something was not right, we fixed that stuff in that industry because it was directly linked to FDA requirements for the manufacture of that product. But for the most part, the industry just kept adding gas. And so along, fast forward, I was a train company. I knew that the Montreal protocol had taken place in '87 because they were already testing. I got to go to the R&D center for train, obviously, if I'm corporate, watching R123, the replacement for R11, as they tested and worked their way toward creating the chillers that would work with this refrigerant. And it was highly aggressive on gaskets and seals and motor windings because the motor is inside of the, it's a hermetic motor. The refrigerant flows over the motor during operation. So we watched it. They first put 123 into an R11 machine, and it was only like 45 seconds before the aggressive nature of the refrigerant just ate up all the motor winding materials and then just flashed because it now just arced. And so they got to work. They worked with a company that made gaskets for the space shuttle. They worked for the good one. It was two companies that worked on space shuttle gaskets. One wasn't so successful. We lost the space shuttle, obviously, but they engineered it. They got the motor winding formula right on the gaskets and seal, and 123 has been with us up until 2020. They quit making it end of 2019. It's very low ozone depletion potential, very low GWP, but it'll be missed. And as Ted says, they don't make enough of it for the people that do have the chillers. They're going to have to rely on the reclaim market. So bottom line, refrigerants started changing. I was a train company so I saw this happening, and I got tired of the cold in La Crosse, Wisconsin. I knew better. I lived in Albuquerque, right? I lived in Texas. I lived in Florida. I knew you didn't have to live at -40 in the winter. So I finally had my chance to get to the town of my choice, Phoenix, Arizona area, where I came when I was 12. And I said, I'm going to move here someday. And I did get here when I was 38. So I show up down here to work for an electric utility, pushing demand side management, which is reducing on-peak energy for the utility so that we could maintain that, so we could get more customers with the same transmission and distribution lines, right? If you can have them turn off their big chillers and half their lights on an on-peak day, hey, you just increased your transmission ability, because now you can serve more people without having to put more infrastructure in. My specialty was thermal storage. I looked at all those fire water tanks out there. You ever been to an industrial site? You see a big old tank and you think it's there for fire water, so that if there's an emergency, they got plenty of water on site, regardless of the utilities around it, so they could put out fires or do whatever. Well, if you put insulation on it, put an internal header system, and it's close to the chillers, you can make that into a big old thermal storage tank. Or otherwise, you find one and you bury it in the ground in concrete, like I did down at my high school, just down over there. You can walk by the pickleball courts and see the manhole cover to the thermal storage tank that's attached to my high school. So those are the kind of things I did back then. But the one thing I did was I knew these regulations were coming. So I decided to I was a government, Salt River Project here is a quasi-municipal. So it's a government utility. I contacted the EPA, got a hold of a lady named Sue Stendebach, who at the time was in charge of writing the stationary refrigerant regulations. This is not circa 1991. The regs didn't hit the streets till August of 93. Okay, even though we had to stop venting July 1 of 92, but the regs weren't done yet. So I said, we want to put on a seminar about this here in the Phoenix area, because we had the Motorola's and the Intels, some big organizations here, because air conditioning isn't what do you call it, a luxury here. anywhere in the South, air conditioning, from Atlanta all the way over to here. Air conditioning is not a luxury. It is like necessary for life. So basically, as the numbers were coming in, I think the final number was around 3,500 people wanted to come to this thing. And so we said, that's a lot of money for us to, so we teamed up with the other utility here in town, Arizona Public Service. So between the two of us, we had to use Gamage Auditorium at the Arizona State University, because it's one of the few places where you get that many people. So we put that seminar on, and then I collaborated with her and her team for the next couple of years, because she could call me. I didn't own a chiller. I didn't manufacture anything. I had no skin in the game. So that's why government to government, I could pay her expenses to come here, government to government. And so everything's above board. And so it was just one of these learning experiences. And of course, deregulation was confronting the electric utility industry, and they got all crazy because 95 was coming up, and that's when something had to happen. And they thought, oh, we don't need the marketing people anymore to tell you about energy efficient lights. We don't need the demand side marketing people to tell you about this stuff. We don't need any of that stuff. We don't need people in the residential to tell you the difference between gas and heat pumps, gas heat and heat pumps. We'll just let everybody go. So they let the whole marketing department go, and didn't realize, because they had no clue what deregulation meant, right? Because they're utilities. So I looked around. I went to Honeywell for about a year, and then decided to join a little software company called ESS, Environmental Support Solutions, which I eventually became part owner of too. And we started the business of refrigerant compliance. That was a very simple little desktop product. It wasn't powerful like TrackRef, but it got the job done for thousands of people over the years. It was sold as DuPont Refrigerant Manager. It was at a lot of the supply houses. It was sold as Train Refrigerant Manager. Train sold it. McQuay sold it. Thousands of copies went out there, and these were those standalone things. Stick them on your computer. Well, and they started at DOS, and then Windows 3.1. I mean, it was that. It started out on big floppies, then the little floppies, then CDs. So as it progressed, the early people that were investing in compliance were the technicians. They wanted a way to quickly document, because they remember school. They remember that they were responsible for that refrigerant. Now, over the years, a lot of technicians forgot that, but in the beginning, there was a lot of them that wanted to do that. Not every one of them. The old guys, nope, don't want to do it, like anything else. So it was a strange time. A lot of my activities early on were because I had an association with electric utilities. One out of St. Louis contacted me to come do contain, convert, replace audits of their customers. We're looking at that again right now. This was CFC chillers. Should we contain the refrigerant, which means keep running this machine till it's end of its useful life, convert it to an alternative refrigerant, like if it was R12, which is going way up in price, should we put 134A in it, right, for the rest of its life? Or just completely replace it because it's at the end of its life. And so this was the strategy that we're at now. We've got all these clients wondering, what are we going to do? Because we got refrigerants that are go away, do this AIM Act, right? There's going to be consumption. So what is the right strategy? Well, as you'll find out sometimes, the beam counters will put on a 40-year life on a big piece of refrigeration equipment. And they won't let you change it for 40 years. And most of that stuff, you look in the ASHRAE, says it's got a big chiller, maybe 25 years, water cooled chiller, 25, it's useful life. Yeah, you can drag it on, but so there's a conflict, accounting versus actual in the field types of things. So, but anyway, those are the things that we looked at. Now, here's something you learn. If you walk into the parts department, the Train company or Carrier or whatever, big chiller people, what strategy do they promote? Contain. They want you to contain the refrigerant in that machine so they can sell you the parts, okay? You go to the service company on the door around the corner of that same building. What do they want you to do? Convert it, because they want to go out, do all the stuff with their service guys, put the new refrigerant in. Makes sense. But then you go up and see the prima donnas in the front of the building, the sales engineers. You know, they get a set of plans. They go 1, 2, 3 chillers, 12 air handling units, 60 VAB boxes. I'm done. Oh no, Steve came up about 20 years ago and said, now you got to do controls. But anyway, so you got the controls too, the digital controls. So that's in the same company, 3 different doors, 3 different solutions. So it's up to you as the owner to figure out what's right for you, because you know the book life, the bean counter did. You know the history of that appliance. That's what dictates. You know the supply you have coming for, or access to it. And you do that through communicating with your suppliers, your service people, if you're going to have enough refrigerant to make it to the end of its life. But those are the kind of stories that we're here again right now. I was doing this in the 90s. You guys, I'm out of here tomorrow, right? This is what you got to do. You got to look at this stuff and make the informed decision for yourself. Because if you walk to the vendors, depending on which door you go in, different story, right? But at least you know that up front. So know who you're talking to. Compliance. So
Yeah,
that's.
Steve, I had a question about compliance, because you mentioned that when you're working with some of the pharmaceutical companies, the only compliance you needed to follow was FDA compliance. Was there any other compliance you needed to worry about at that time in history, or was that just not a
Yeah. It became the. In fact, Sue called me one day, and they found out that the industry wasn't fixing anything as they were trying to write the rules. So they approached the environmental committee there in DC, and that's where all the congressmen and the senators are, and there's lobbyists come in too from the different industry, like the Building Owners and Managers Association, ASHRAE, whoever, the industry groups, the lobbyists.
Right.
And they said, well, we found out people aren't fixing anything, and this is horrible. So we want people to shut their systems down and fix it before they put refrigerant in. And a couple of senators just kind of blew up and called them names, tree huggers, told them to go back to their cubicles and find a solution that wouldn't bring America to its knees by forcing overbearing federal regulations on homeowners and small business people. Does that sound familiar? But so that she called me and says, well, what's going on? Why? I said, hey, we didn't fix nothing. I said, this is a big change to the industry to actually go out there, stop operations of that equipment. You got to move, shuffle things around. And the food industry's been doing it forever, because when that meat and cheese get warm, you got to take action, right? But when someone's warm in a building, unless it was the big guy or the big person with the title, it didn't move so fast, But now that we have, they put on, you got to repair in 30-day requirements. You can add refrigerant, but you got to fix it in 30 days. And they came up with leak rate triggers and all this stuff. You had to calculate it. So most of the time when you're adding gas to stuff, you're going to go over that little trigger rate. They have since lowered those trigger rates. For instance, it used to be 15% for comfort cooling. Now it's 10%. It used to be 35 for industrial process. Now it's 30. So because they have strong lobbies. The food industry used to be 35 too. Now they're 20 because they didn't have as good a lawyers as the chemical companies did. Does that all figure out? So yes, we did have some things put in place. Then along comes California, little old town called South Coast. They put their own regs, said, hey, you got to register your equipment with us, and you got to give us $100 every 2 years and tell us how much gas you added. And you got to go out and leak audit that thing. You got to go look at that thing once a year and see if there's any leaks. So that was the beginning of leak inspections. Little old South Coast, which is LA County.
What year was that, Steve?
94. They even had in the beginning that you had to get a techs had to get certified. This was like 93, 94. In LA, in South Coast, because the feds hadn't gotten their program going yet.
So they beat everybody.
They were early on. So
right,
it all started, the CARB rules really started down in LA, which was called the South Coast Air Quality Management District, which is like LA, I told you, LA County, Irvine, Orange County,
Orange County. Okay.
Out into the desert, the desert regions. But
okay, go on.
That was the beginning of regulations. So, and then there were stupid regulations like the state of, for instance, City of Austin had some, Colorado had some, but it was South Coast that was the first one that said you have to send your information to us. Now they just collected the money. They took all the data that was sent in and they sent it up to Sacramento. And that's where CARB got all of its early data as they developed the rules that kicked in around 2011. But it was all the stuff they mined. And it was very, I had clients over in LA that would call me, Steve, South Coast inspectors are here for my boilers, which they really go after. They walked right by 3 of my chillers, didn't even ask any questions about it. And I didn't tell them that they have refrigerant in them. So there wasn't a whole lot of participation. And that's why CARB, when they initiated their stuff, they actively looked for stuff. They looked at permits and things, and they worked with their little air like the air boards, local air boards, and said, hey, look for this stuff that now you can find stuff. So now you can go out and collect fine money if these people didn't register. So it was a whole different approach to make sure that everybody was signing up that needed to sign up, because they have aggressive environmental goals, right? In California, just like the country's trying to pull together right now.
Yeah, very aggressive.
But yeah, the regulations are there. They've been there. They've just been refining them over the years. In the beginning, it was just ozone depleting refrigerants. Now they're expanding those out to all refrigerants except for the exempts. Exempt refrigerants, I like to tell people, are the easiest way to think of them is, will it kill you if things go bad? Ammonia, yeah. Very good refrigerant, very efficient, energy efficient refrigerant, but if it leaks into your face, not a good thing, okay? CO2, super high pressure, super hard, industrial sites, I used to see them, but they're always surrounded by concrete, reinforced walls. So if something blew up, it wouldn't hurt the cars in the parking lot, okay? Try to put these into grocery stores and they've got some now fancy transcritical, keeping the pressures just in check. That's great if you don't have any power outages. But anyway, just these very complex, very expensive to do. And yeah, if they blows all the refrigerant out, it's CO2 is CO2. And then the propanes and the isobutanes, so the hydrocarbons. Those are the exempt refrigerants, basically. They're exempt from the EPA I call them the Freon rules, or the CARB rules, but they're highly regulated. Ammonia is highly regulated by the process safety industry, right? Same with CO2. You got to have skilled people. You got to know what you're doing. You got to make sure you've reinforced things around there. So for the same reason, if there's a problem, an explosion from that system, you don't want that to affect your customers or your employees. So yeah, we got challenges. So, but moving forward, the good news is what we're seeing now is compliance has been there for years. It kind of, the last administration kind of stifled any environmental compliance. Companies like Trinity, consultants I'd worked with over the years, but they had to lay off environmental consultants. I got laid off in 2018 because the people paying for compliance just dropped off it stopped because the former administrations relax every environmental rule out there. And it's starting to pick up again, because now we're seeing things sneak in like what? It's called sustainability. And then if there's companies that are trying to, yeah, we're going to be sustainable. Well, now there's people that are saying, prove it. Prove it. What do you have to prove? Okay, so
right,
as I leave this industry, now it's even going to get records. It didn't matter. I could ignore the under 50-pound stuff. Oh, you want to do sustainability? Oh, well, then you better track everything. Now, my former clients that I always dealt with, I had them track everything for that very reason, because I had a university in Northern California right around 9/11 timeframe, and one down in close to Berkeley that got busted. They didn't pay much, but they weren't tracking anything under 50 pounds. And so when you use if you're a big campus like in the north, an agricultural campus up near the state capitol and of California, and you have 28,000 pounds of R22 you bought in 3 years, but only have 7,000 pounds of records because that's your big stuff. People are going like, what happened to the rest of that? Oh, it went in the little stuff. And so now it's a he said, she said. You see? Well, now we're back at that because sustainability is going to require, you throw the rules of compliance aside. Now you've got to assemble and gather data so that you can prove to those people that are going to be checking that are you going down like the Green Show program does with, but it's not enforced that on the supermarket people because they can choose to not track under 50s or track under 50s. But for these companies that are claiming I'm gonna, we're gonna get some Wall Street cred for this, you got to prove it now. So that's the future of where compliance and sustainability have parallel paths. So because you're doing the same thing that you do for big stuff as little stuff. And then if you're trying to reduce emissions, you're going to try to fix that little stuff, but you didn't have to do before. You could have let it ooze and keep topping it off. So now you're trying to reduce your emissions. So you're actually going to try to fix that. So that's what I see as the future, is that the platforms like TrackRef will be used in, to supply that type of information. And then, which begs the question, why do they have work order systems and why do they have TrackRef running in parallel? When I started, guess what work order systems were? You went down to the engineering room and you pulled cards out. Every piece of equipment had a physical card. And then you wrote what you did on that card and you pushed it back in, and then you pull out another card. It would tell you what to do. And then it had date fields and name fields and notes fields. So you would document everything you did, but it was all on paper, right?
It was all on paper on the piece of equipment.
No, it was in a great big, it's not a box. It's like, you ever go into a place where they file plans?
Yeah, like the flat
all
drawers.
The plans were in a nice little drawers.
Gotcha.
But it was similar to that, but smaller. So you actually had, so you'd go up and look, and they would have a label on it, and you'd pull the drawer out, and that was like chiller 1.
Wow.
And it had the tasks, and then when you did them, and then you had the places to document that you did them. So
Gotcha.
that's the beginning. And so the same concepts were just carried forward when computers became available. But they were good at tracking because system, our refrigerant compliance is a system, right? In the work order mentality, it could be multiple pieces. If it's a built-up system, it's an evaporator section, it's a condenser section, it's the metering device section, and it's the compressor section, because these all might have been field built up. And so each one of these things or groups of these things might have had their own thing within the work order system, which made it very hard when you said, oh, well, those are all stuck together and they have this much of this type of refrigerant in it. So time and time again, we've got these big lists of 700,000 lines of information on assets and no refrigerant type or refrigerant quantities, right? To my team members that have looked at this, we've got a big company give us 775,000 lines on a spreadsheet. And now I think we had 2,400 of them were useful. 2,400 of their almost 1 million assets had useful information. How's that? So the next person coming in, that's your challenge. See if you can reduce that 700,000 line items to find the usable stuff to put in refrigerant systems. That's the challenge. What kind of questions do we have? I mean, compliance is here, sustainability, they're merging. We talked about contain, convert, replace. We're right back there again with a new HFO. These HFOs that we have right now, they're just temporary. We haven't got the final solution yet because they still have HF, right? This 448A that we see in a lot of this going into the grocery stores. They're taking, almost 4,000, one pound of 404A 507, which is a nice medium and low temp refrigerants. Around 1 pound equal 4,000 pounds of refrigerant. Well, the 448 is down around 1,300 pounds. So that is a big drop. But some of these new rules, 700, are going to be 750 or 125, 150. So we're still looking for that aren't hydrocarbons. So there's a new class of refrigerants that the A2Ls, which didn't exist. L, if it's an A2, that means it's flammable. And the L now is a lower flammability, but it's still flammable. I always attended these seminars over the last few years on the A2Ls, and the best way to think of those is when propane goes, you get a spark, propane, you can't outrun it, can you? Goodbye, go gas, go boom. That's what I always said when I was a utility. Don't get a gas chiller. Don't get a gas heating in your house. You go gas, go boom. Ever see the roofs blow off of houses? I never saw a heat pump do that. So that was I'm pure electric. Okay. So A2L, when it's sparked, you can walk away. I think, all right, I'll let that happen. Not in my house, but yeah, if they get the codes right and the ventilation right and there are sparks, and with controls, we're seeing more. I'm seeing them now. They're putting leak detectors right in the main control panels. Why not? DDC, I was here to see it and help it grow. Get digital controls the way they should be. The glass cockpit. Why not have leak detectors in these machines? It's just electronics. Oh, that's right. We can't get any chips until Intel builds the rest of their plants here in Phoenix. And Taiwan Semiconductor gets theirs built too. We're going to have a lot of chips flowing out of Phoenix here in the next few years.
Yeah, right.
So they are multiple hundreds of billions of dollars being spent here right now. So if you like to make chips, move on down here. You can't find a house, but move on down. What questions do we have out there from the industry?
Well, I've got one, and I'm trying to determine how to best articulate it. You've got over 40 years looking at this technology and have watched it evolve. But obviously most people who are facilities managers, operations managers, or CFOs aren't anywhere near that. What are the top few things you would tell somebody who needs to be worried about these things, but has frankly either not given them much thought, but now needs to?
It starts with that contain, convert, replace. You got to have a strategy for what's happening using the lessons learned from last generation of refrigerants. Nothing happens overnight. There's still CFC machines out there, and they will be till the end of their life, the 40 years. They didn't get converted. They're still running R11. Now they're few and far between, but they're still out there.
So knowing your assets.
Here was the secret to success. Yeah. We see this on people that might join us as a customer. If there's not a fire under your seat from your boss, if senior management isn't behind refrigerant compliance and sustainability, it doesn't happen. It has to be top-down driven. Okay. Trust me, the companies that got burned, I worked with a lot of them around 9/11. There was a lot of enforcement action going on. The baking industries, okay, the first were the Sara Lee's and the Hostess brands got $5 million fines. Well, the state of California is doing $5 million fines now, but back then this is in the 2000 time frames. Then they went after pharmaceuticals, the Roaches and the BMF, Bristol Myers Squibb. So they had a lot of those in the news. So this started industry sparking, furies. I mean, went to every freaking bakery in this country. I had to hire a guy. Now he's the only guy there. But in 2000, it was crazy. We're spending 44 weeks a year on airplanes, going to all these places to get them tuned up, ready to go. And so it's the big bust that we've lacked. You got to have fear to have compliance. So the new fear is sustainability, and the enforcement, maybe not so much from the EPA. EPA is coming back, But that's what was sold refrigerant compliance, was fear of my boss firing me if I didn't do it. Fear of me having to tell the Securities and Exchange Commission that my company just got fined and I can't subtract that fine dollars from my operating budget. So it's all about fear. It had been. Now, maybe there's a change. It's because of sustainability coming in. It's, let's do the right thing. Okay, the right thing is to find out what our emissions are and then do something about it. And the only way you can do that is track it. And then keep track of it.
Does that come from, you said fear comes from, you got to have fear to have compliance, and
that's from my day,
right,
yeah.
Right. And fear from, fear from your boss coming down. So now with sustainability, you could get fear or at least concern from consumers.
Correct.
Yeah. Okay.
Loss of clients, loss of
Investors.
your people, investors. So that's a new kind of fear. So that's what's got to be there. I've always said that you got to have some motivation. People, when I'd watch companies, there were some companies where they were, I just talked to a guy, they build top secret airplanes. In fact, he said they're redoing their plant down in Marietta, Georgia, and they've walled everything off because they're building something that no one wants to be. This is where they built F-22 Raptors and the other things. And now it's all skunk works. The whole plant's going skunk works because they refurbished all the C-5As. They got all these big C-5As are the biggest planes on the planet. So they're all now skunk works again. And so no one knows what's behind those walls. But I was talking to him and they got scared back in the 90s. I went to that site every year. Now my compartment, he does it by Zoom now, but he's my client's retiring at the end of this year too. But we're still friends. But he's seen now what's going to happen when he's gone. I saw this time and time again when the guy that knew everything was going to pick up and carry on. I've had some people pass away this past year that I knew, and they were in their 40s. But strong refrigerant compliant, but they were injured technicians that became the refrigerant compliance guy, because they were really good. They knew what the industry, but they physically couldn't do the technician job anymore, but they could do compliance job. They could run that computer. So, but it's sad to see that happen.
What's your concern as the next generation comes along? I mean, you've been, like you said, you've been in the trenches from the very early part, days of it. Yeah. That institutional knowledge, you're retiring today, is going away. What's your concern about replacing people with that kind of experience and that kind of rationale? It's
in the food supermarket industry. It's tough.
Yeah.
Because it's such crazy industry. The majority of the clients I worked with were Title V's plants, the dirty and dangerous, I call them. And so they have highly tuned, skilled environmental people, air, water, waste. Okay. And they have different sites say, you're the air person.
Right.
I mean, because they had to sign off every year. The plant manager had to sign off that they were in compliance with all air rules or all water rules, waste.
So it's all become specialized, just like everything else.
Yeah. So the fear was there. That's the fear. That's built-in fear. It's there every day.
Right.
You get away from Title V. You don't have an environment, a professional environmental department, because a lot of, in the early days, it was the safety guy, because feds mandated a safety guy, right? Well, why don't you do that environmental stuff? So, and then you go to it's not environmental health safety. It's the last thing. No, it's SSE, safety, security, now environmental. Right. But different people came from different backgrounds. So the ones in the dirty and dangerous, where you have the Title V permits, those were chemical engineered, degreed, studied people. Okay, they know they know exactly how to calculate a leak rate for refrigerants. They know those regs inside out and backwards, as they do everything in the CFRs.
So how's about we talk about those HFCs? Just read the facts if you don't believe me. What's your leakage, disposal and recycle? It's key, because we can do this together if we all stand together